Great. Now, let's first and foremost pick our question. Of course, we'll be using a sequence of writing options and then giving ourselves some 10-15 seconds to give ourselves time to figure out the answer. Then we'll pick the answer together. This is because most of these questions would be non-calculation based questions. As such, it becomes important for us to be able to use these questions in entirety and pick our brains and interest towards this question. This is going to be the focus for our picking of this strategy for this subject. Now, let's pick our very first question of the day. Number 1. So for these questions, we would not have more than 15 to 20 seconds. However, for the calculation-based questions, we will increase the timeline to 40 seconds so that, of course, we take notes of the solving specialized timings. But for objective questions like this, we should be able to solve them with a little under 20 seconds. So this is our first question of the day. Which of the following gases is the most dangerous pollutant? Is it hydrogen sulfide? Is it carbon monoxide? Is it sulfur oxide? Or is it carbon dioxide? So you have 20 seconds. Come up with your own answer. Think about it. Think of exactly why you are picking that answer. And then we'll continue from there. 20 seconds. The time runs very, very fast. Let's see your answers in the comment sections. "15 seconds left. "10 seconds left. 5, 4, 3, 2, 1. And we are done. All right. So that is that. Which of the following gas is the most dangerous pollutant? The answer to this question in the clearest possible form is in fact carbon monoxide. This is the answer for this question, carbon monoxide. And in fact, of course, you can call it carbon monoxide. You can also call it carbon 2 oxide, right? Carbon 2 oxide. That is another way of calling it. So, of course, this carbon dioxide can also be called carbon 4 oxide. So, carbon monoxide, you can also see it as carbon 2 oxide. So, if you see it written as this, that's fine as well. It is a colorless, tasteless, and odorless gas. Of course, it is not as abundant in nature as the counterpart carbon dioxide, which I'm sure you are so familiar with. Remember, we breathe in oxygen and we breathe out carbon dioxide. However, carbon monoxide, as you have it, is what you mostly produce when you have exhaust from your car systems or exhaust from your engine systems in general. And you'd agree with me that this exhaust you have from these engine systems are in fact very, very harmful. In fact, if you are in a motor vehicle and you are passing by the side of a tanker that is coming out with a large amount of exhaust, you'll find out that, as a rule of thumb, you are always trying to cover your nose so that you don't breathe in that harmful substance. And of course, that substance, which is carbon monoxide, is not just harmful in terms of you breathing it in. In terms of the way it corrodes the air and the atmosphere in terms of reducing the content of oxygen it has, it is in fact a very, very dangerous pollutant to talk about. So the answer for this question is in fact carbon monoxide. Let's quickly pick another example or another question. Which of the following is an example of a mixture. A, common salt. B, blood. C, sand. And D, washing soda. Okay, we have another question. Which of the following is an example of a mixture? Is it common salt? Is it blood? Is it sand? Or is it washing soda? Again, you have 20 seconds. Think, ruminate, think about the constituents of these 4 options you have and try to pick an answer. Let's go. Of course, put in your comments. All right. B. Let's keep the comments coming. You have 10 seconds left. B still. Okay. B. 5, 4, 3, 2, 1. And time up. All right. Beautiful. Let's quickly see the correct answer for this question. So, as picked by the majority, B is in fact the correct answer for this question. Blood is an example of a mixture. Now, it might be so strange. You'll be like, okay, if I were to probably pierce myself and I have that red substance come out, which is obviously blood, it's just looking liquid-like. How can that be a mixture? Remember the definition of what a mixture is. A mixture is coming with 2 or more constituents that cannot be directly chemically mixed together. Remember, we have a concept of compounds and we have the context of mixtures. Compounds can be completely chemically mixed together and can carry out the various chemical reactions in order to form them. However, for mixtures, you cannot have that chemical bondings, right? That is why we separate mixtures using the various separation techniques that we have. Now, if you look at common salt, of course, common salt, which you have, is in fact a compound. Usually, we refer to it as the sodium chloride, a compound in its full sense. If you have sand, sand is just one constituent. Regardless of wherever you pick sand from, it is just one constituent that you have. If you have washing soda, of course, there is a chemical compound name for washing soda as well. All of these are compounds. This is a compound, this is a compound, and this just has one single constituent. However, for blood, blood is in fact a mixture that contains solid and liquid components, which might be very, very strange. You'll be like, it's just all liquid. How can it contain solid components? Yes, it can. The liquid components within the blood is, in fact, is the plasma part. The plasma part of the blood is the liquid component. And within that plasma part, you have a lot of proteins, you have a lot of salt, and you have a lot of water. That is the liquid component. And in the solid component, we are talking about the elements or minerals that form the constituents of the blood. So because of these 2 separate distinct components that you have within your blood samples, then that is why blood qualifies as a mixture. I hope that's clear. Beautiful. So we have ourselves our second question. Let's quickly move forward. Let's quickly move forward to our third question, which in fact will be our first calculation-based question for this class. Of course, as we have said, a calculation-based question would give ourselves 40 seconds to give ourselves enough time to attempt them. So get, of course, your pen and paper handy. Okay, so this is the question. Calculate the percentage by mass of nitrogen in calcium triazonitrate 5. Calcium has a mass 40, nitrogen 14, and then oxygen is 16. All right, we have our 40 seconds. The very first thing as a hint that will help you solve this question is correctly bringing out the chemical formula for this compound. If you can write out the molecular formula correctly, then you're on your way of solving this question. So we have 40 seconds. Our time starts now. All right. Put your pen to use. In this case, we are not going to provide ourselves with options, so we limit the opportunities for you guessing. Try to put your pen to paper and come up with an answer. 30 seconds left. $20 seconds left. Remember, you are looking for the percentage by mass. So write your percentage figures in the comment sections. 10 seconds left. 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so I saw some amazing attempts within the comments. Let's look at the final results together. Now, remember, as I said, the very first thing that must be your first point of concern is what exactly is my chemical formula? If I can get that correctly, then I'm good. Now, the chemical formula for calcium thioisonitrate 5 is in fact CaNO3 2, like this. This is the formula. Now, question is, how exactly do I know this? Remember, in our concept of IUPAC nomenclature and in concept of naming chemical compounds, remember that we have said that the most important thing is in fact the oxidation number of that particular element within the compound. Now remember, calcium as an element has an oxidation number of +2. Now, the normal NO3 radical, carries what? It carries a charge of -1. That's the NO3 radical, -1. So if it's carrying -1 and this is carrying +2, remember, this is how we do it. We take +2 charge, we take the NO3 minus charge, and then we cross multiply the charges. This is how we do it. And then, of course, without the sign, this is -1. So 1 times Ca gives us Ca, 2 times NO3 gives us NO3 subscript 2, which is what we have here. That is how we named chemical compounds. This is a method of naming chemical compounds. This is the first stage of IUPAC nomenclature, even before you now start talking about naming it in its totality. This is something that comes in our very first concepts learned under chemistry. So this is the compound. Now that we have the compound, the next thing to now find is the relative molecular mass. Now, calcium is 40, nitrogen is 14, oxygen is 16. So it means that if you were to find calcium thioisonitrate, we'll be talking about 40 plus, now this one, 14 plus 3 times 16, all of them multiplied by 2. So let's just put the 2 here, which is the 2 outside, right? And then bring all of this together. What do we have? 40 plus 2 times 3 times 16 is 48. No need to a calculator there. 48 plus 14, we are talking 50. We are talking 62. So let's confirm. 3 times 16, that's 48. 48 plus 10, that's 58. Plus 4, that's 62. Good. And then we have this to be 2 times 62, that is 124. That's 40 plus 124, which gives us 164. That is the total molar mass of this compound. Now the focus is to find the percentage by mass of nitrogen. Now, how many of the nitrogens is within the compound? We have 2 of it. Why? There is 1 of it here. Then multiply by the outer subscript 2. So that means you have 2 nitrogens. Beautiful. So if you have 2 nitrogens, percentage by mass of nitrogen, we will now have this to be 2 of this divided by the total mass times 100%, which will now give us 28 divided by 164 times 100%. Now, at this point, what do you have? You can simply use your calculator simply to get and evaluate this value. And evaluating this value, you should get a value close to 17.1%. Of course, you can confirm the values and see if this is exactly what you have. But the process is very, very straightforward. First, generate the molecular formula. Next, generate the molar mass. Next, evaluate the molar mass of nitrogen with respect to the total molar mass and put it in percentages. That gives you the final result for the percentage by mass of nitrogen. This is how to calculate this. Of course, you see that there are a lot of steps that I could have jumped. Could have jumped this one and just moved straight to this particular final answer without the need to write this and then find the percentage by mass. These are steps that you can still do within 40 seconds. So one thing you'll have to note as far as the chemistry part of your multiple choice is concerned is that the best and effective way of saving time as far as chemistry is concerned is stealing time from the non-calculation based questions so that you will have enough time to solve the calculation based questions. Now, all of the questions are allocated in an equal and general time frame, right? So you should have like 30 seconds for each question. If you have a non-calculation based question, then you are expected to try as much as possible to solve that non-calculation based in like 10 seconds so that you have kept 20 seconds. And that 20 seconds, you can now shelf it towards calculation based questions like this that might take more than the allocated 30 seconds. So that's a trick to conserving and efficiently using time in your chemistry section. Now, let's take another question. This will be our 4th question. The volume, so let's have another calculation-based question of a given gas is V centimeter cube and the pressure is P millimeter mercury. What is the new volume of the gas if the pressure is reduced to half at a constant temperature? So we are going towards gas law now. The volume of a given gas is V centimeter cube and the pressure is P millimeter mercury. What is the new volume of the gas if the pressure is reduced to half at a constant temperature? So let's solve this. For this one, we are going to give ourselves 20 seconds. Yeah, it's calculation based, yes, but it's calculation based with respect to just symbols. So just think of this like a subject of the formula case. So what would you have as a final answer? All right, to help ourselves out, let's provide ourselves with some options. So A, 4V centimeter cube, B, 2V centimeter cube, C, 1/2 centimeter cube, and then D, V centimeter cube. So attempt this, 20 seconds. Your time starts now. $15 seconds left. Yeah. Put in your options. Drop your answers in the comments. 10 seconds left. 5, 4, 3, 2, 1, and time up. All right, so I am seeing a lot of diverse comments. I am seeing B, I'm seeing C, I'm seeing D. All right, let's see which of them is in fact the correct answer. Now, this is gas law. In fact, this is in fact Boyle's law. And what are we saying? We are talking about the fact that at constant temperature, the volume and the pressure have in fact a relationship between them. And what's that relationship? The volume is in fact inversely proportional to the pressure. And in essence, or in mathematical forms, we are saying P1V1 is equal to P2V2. This is the mathematical representation, right? Now, at constant temperature, P1 has been given to us as P, V1 has been given to us as V, P2 now has been said to be half, so we have P over 2, and we are looking for V2. So put all of this in, what would we have? We have P1 V1 will now be PV, will now be equal to P2 V2, that's P over 2 V2. So make V2 subject of the formula. This will multiply here, you have 2PV is equal to PV2. So P cancels, what do you have? It means that V2 is equal to what? 2V centimeter cube. So the final result is in fact B, as some of us picked. So the major thing for this is understanding which of the gas laws exactly are you making reference to. Once you can adequately and correctly pick which of the gas laws you are talking about, then picking the formula comes next, and then applying the formula straightforward. As far as gas laws are concerned, it's just the realm of application of formulas. So that solves this particular problem. Let's quickly move on to another one. So, of course, just as I mentioned earlier, all these questions are in our question bank repository available on our website, www.yourstudypad.com. And you can simply go there to make more practice for yourselves. So, number 5, which so we have ourselves another 20 seconds question. All right, so the question goes thus. Which of the following terms indicates the number of bonds that can be formed by an atom? So when we talk about bonds, we are talking about the chemical bonding process. A, oxidation number. B, valency. C, atomic number. D, electronegativity. So you have 20 seconds. Tick-tock, your time starts now. $15 seconds left. 10 seconds left. Interesting. I'm seeing a lot of options, a lot of suggestions. 5, 4, 3,